All right, so here's question number 6 from 2012. It's a non-calculator question, so this is actually going to review a lot of stuff that I think some of us have forgotten or struggled with. So it's a great opportunity to pay attention and brush up on the things that we struggled with. Okay, so we have a domain of time right there. We also have the velocity function. And then we have a position at a specific value of time. So we're going to use that, not necessarily all at once, but let's see what's going on. So par day. Over that domain, when is the particle moving to the left? So a particle moves to the left when the velocity is less than 0, aka negative. So our job is to figure out when is the cosine of pi over 6t less than 0. Well, for starters, we need to figure out the critical value. A critical value is when the velocity is actually equal to 0. So that's when the cosine of pi over 6t is equal to 0. All right, so let's think about when cosine is equal to 0. I'm going to draw my unit circle here. Okay, here cosine is 1, so that's 0. Here, cosine is 0, so that is pi over 2. So when pi over 6t is equal to pi over 2, cosine there will be equal to 0. So when we multiply by the reciprocal to get t alone, we're going to multiply by 6 over pi. That's going to give us t equals 3. Now 3 does fall in this domain, so that is a potential, that is a critical value. All right, let's keep going with our unit circle. Here, once we go down, we're at pi. Cosine is back to 0. But if we keep going, cosine will now also be equal to 0 at 3 pi over 2. So this was pi over 2, this is 2 pi over 2, and this is 3 pi over 2. So when pi over 6t is equal to 3 pi over 2, cosine there would be equal to 0. We're going to multiply by the reciprocal again, which means t is going to give us 6 over pi, which is 18 over 2, which is 9. Now 9 also falls in the domain, so it is a critical value. But, cosine still keeps going. We're going to get back up to here, which is back to 0, which is also 2 pi, because it's 4 pi over 2. Cosine, however, there is equal to 0, so that's not a potential candidate. But if we keep going, this would be 5 pi over 2. Cosine is equal to 0 at 5 pi over 2, so let's just look here. So pi over 6t, when that is equal to 5 pi over 2, cosine there is equal to 0 as well. When we multiply by 6 over pi, we get 30 over 2, which means t is equal to 15. And if you notice, we now know to stop because t cannot be bigger than 12. So our critical values really are only 3 and 9. I'm going to draw my number line for going from 0 to 12. I'm going to put a 3 in here and a 9 in there. All right, now we're going to test the values. So a good test value there is the value of 1. So we're going to plug back into the velocity function to determine what is cosine there. So if I plug a 1 in place of t, I get cosine of pi over 6. Pi over 6 is 30 degrees, so 30 degrees is going to be in quadrant 1. Quadrant 1, all the functions are positive there, so cosine will be positive there. Okay, let's pick a value of, let's say, for example, 4. So that means we are evaluating velocity at t equals 4, which means that would be 4 pi over 6, which is 2 pi over 3. So 2 pi over 3 is going to give us, if you want to think about it in terms of degrees, 2 pi over 3 is going to be 120 degrees. So 120 degrees is in quadrant 2. Here, only sine is positive. Therefore, cosine there would be negative. All right, and now let's pick a value of 10 for testing between 9 and 12. If I plug 10 into the velocity function, it would be 10 pi over 6. Well, 10 pi over 6 would be 5 pi over 3. So 5 pi over 3 in terms of degrees is 300. So 300 is going to be in quadrant 4. So in quadrant 4, that's your C for calculus. All students take calculus. Cosine there is positive. So this question is asking for when is it moving to the left. So therefore it would be moving to the left over here. So it's moving to the left over the interval from 3 to 9 because velocity there is less than 0. Can I move this? Not sure if I can move it. So there we go. The velocity there is less than 0. And we have all of the work here to rationalize our answer. All right, part B, floating away here. Okay, for part B, write but do not evaluate an integral expression that gives the total distance traveled by the particle. So let's review that concept. Total distance is equal to the integral of the absolute value of velocity. So in this particular case, it wants to know from 0 to 6. So our lower limit of integration, sorry, I keep moving this. Our lower limit of integration is 0. Our upper limit of integration is 6. There you have it. That's all you had to do for part B. Now, that's only worth 1 point because obviously it's extremely easy. But take that point and run with it. Okay, part C. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at t equals 4? So in other words, the first part, we're just getting an expression for acceleration. So if we want to review that concept, okay, to get acceleration, oh my goodness gracious. Hope you guys are chuckling a little bit. It's like watching me at the front of the board in a regular school day, right? Where are you, work? There you are. Okay, so acceleration is equal to the derivative of velocity. So because we know velocity is equal to the cosine of pi over 6t, we need to take the derivative of that. So the derivative of that is going to be acceleration, which is, don't forget the chain rule. So it's the derivative of the outside, leaving the inside the same. So the derivative of cosine is negative sine. Now we leave the inside function the same. Then multiply that by the derivative of the inside. So the derivative of the inside of pi over 6t is just pi over 6. Now we could clean that up to be negative pi over 6 sine of pi over 6t. So that expression there is your acceleration at time t. Now, the second part of this is to determine if it's speeding up, or is the speed increasing, the speed decreasing, or neither. So in other words, speeding up, slowing down. We know something is speeding up when the sign of velocity and acceleration are the same. Something is slowing down when the signs of velocity and acceleration are different. So we need to figure out at t equals 4. So velocity at 4 would be equal to the cosine of 4 over 6 pi, which is the cosine of 2 over 3 pi, which is going to be in the second quadrant. So in the second quadrant, cosine is negative. Okay, so it's a negative number. You don't even have to tell me what it is. You could just say that it is negative there. Then the acceleration at 4 would be negative pi over 6 sine, plug in a 4 there, so it'll be 4 pi over 6, which is 2 over 3 pi. So we have this negative number here, this negative pi over 6. So we have a negative number, and we're multiplying it by 2 over thirds pi, but it's the sine of 2 over 3 pi, which is in degree form, sine of 120, which is in quadrant 2, and sine there is positive. So a negative times a positive is also going to give us a negative number. Now, because signs are the same, we have a negative velocity and a negative acceleration, those are the same, this particle is speeding up. So we would write speeding up or speed is increasing, because velocity at 4 and acceleration at 4 have the same sign. Okay, now we have one more part. Seems like we're gonna need a little more space for that, so I'm gonna scroll up. Here we go. All right, asks us to find the position at t equals 4. So from velocity to get position, we need to integrate. So we're going to integrate. We knew the position at 0, so we're going to integrate from 0. We need the position at 4. I'm going to put the 4 up there. And we're going to integrate velocity, which velocity was the cosine of pi over 6t with respect to t. And then that, by the fundamental theorem of calculus, will give us the position at 4 minus the position at 0. So we're actually going to have to do this without a calculator. Oh no. All right, so we're going to integrate this and get a value. Now, this is going to require u substitution because we're integrating a composition of functions. So because there's no chain rule, we use what's called u substitution. So u would be that innermost function, so pi over 6t, which means the derivative of that would be just pi over 6 dt. Now, it's okay that we don't have that pi over 6. We would just multiply by the reciprocal, so we'll have 6 over pi, then the integral of cosine u du. Now, if I want to keep it in terms of u, I'm going to change my limits of integration to be u. So if I take this 0 and plug it into pi over 6t, that would give me 0, because pi over 6 times 0 still gives me 0. If I take this 4 and plug it into pi over 6t, I'm going to have 4 pi over 6, which is really 2 pi over 3. So I changed my limits of integration. I like to do that because I like to use, less, I like to do more arithmetic, I guess, and less calculus, but that's completely up to you. So now I'm going to just move down. 6 over pi, whoopsie daisy. 6 over pi is going to come down into my answer. And the antiderivative of cosine brings me back to sine. I'm keeping it with u because I'm using my new limits of integration. Okay, so I'm going to do all that work now. So that's going to be 6 over pi times sine of 2 pi over 3 minus sine of the lower limit of integration, which is 0. So that's going to give you the integrated amount of change there. So that's going to be 6 over pi sine of 2 pi over 3. Sine of 2 pi over 3 is like saying the sine of 120. So the sine of 120 is the same as sine of 60. Sine of 60, if you remember, is rad 3 over 2. So it's 6 over pi times rad 3 over 2 minus sine at 0. Now, what is sine at 0? Sine at 0 is 0. So this comes out to be 3 rad 3 over pi. So that is what the integral came out to be. So I'm just going to rewrite this again. I'm going to take this right here and let the reader know that I got 3 rad 3 over pi is equal to the position at 4, which is what we're looking for, minus the position at 0, which they told us in the beginning the position at 0 was -2. So the position at 0 is -2. Which means if I want x sub 4 alone, I need to take this minus -2, which is really plus 2, and subtract it to the other side. So x, or the position at 4, is equal to the 3 rad 3 over pi, and then we're going to subtract 2. So that's your position at 4. This reviews a lot of trigonometry, okay? Hopefully this makes sense. If it doesn't, just please comment or come to the live Google Meet on either Monday or Wednesday, and I can try to explain it a little bit better. Hope all is well. Bye.